All right, Algebra 1, Chapter 3, Section 1. We're talking about functions. Starting off with the definition, we have a relation. A relation pairs inputs with outputs. That's all it does. That's a relation. Okay, a relation is a very bland term. It pairs inputs with outputs. Okay, you're normally talking about numbers, right? X and Y is normally what we call these. X is our inputs, Y is our outputs. And then we have when a relation is given as ordered pairs, the x coordinates are inputs and the y coordinates are outputs. That's what I just said. A relation that pairs exactly each input with one output is called a function. So a function is a special kind of relation that pairs each input with one output. So let's look at example 1. Here I'm going to look at my x's. I'm going to look at my x's. I have -4, 4, -3, 3, -2, 2, -1, 3, and 0, 4. Now the really quick way to decide if this is a function is to ask yourself, are there any repeats in the x category? And there's no repeats, so this is going to be a function. So this is a, we'll say yes, function. Now, if we wanted one that was not, I'm just going to write another point in here that would make it to where it would be not a function. We could repeat one of our x's. We'll say 0, just because that's the one that's right there. And in this point, 0 maps to 4, right? Think about you have an equation, and you plug in 0 for x, and then you get 4 out of it. It wouldn't make sense if we were to plug in 0 and get 3 out of it, right? Or any other number besides 4. So if we had that orange point, it would be not a function, right? Because there's a repeat of the x, and the x goes to a different number, right? Think about this. Think about these 2 points right here. Could you yourself make an equation so that you plug in 0 and you get 4 out of it, and then after that you plug in 0 and you get 3 out of it, right? That just doesn't really make sense, and that's because it's not a function. Next up, we have it written a little bit differently. It's written in a chart here. So we look here, we've got 2, 4, 6, 8, 6 in the x category. The first 6 maps to 2, right? So we plugged in a 6 and we got out a 2. The second 6 maps to a 4. So we plugged in 6 and we got out 4. So this is not a function. All right, so those are looking at whenever they're listed, whenever the numbers are actually listed. Next up, we want to look at whenever it's a graph. So we have a special test, a vertical line test. A graph represents a function when no vertical line passes through one or more points on the graph. So on the left spot here, this would be called like a discrete graph where it has little points. They drew in a vertical line. It only touches one point. We could draw in some more vertical lines, and every vertical line would only touch one point, right? We couldn't draw a vertical line that would touch it twice. So this is going to be a function because it passes the vertical line test. Let's look at the second one. Here they drew a vertical line and it touches it twice. It fails the vertical line test and it is not a function. Now you look here, we could draw a vertical line that would touch just one spot right there. That doesn't matter. It doesn't matter if you can draw one correctly. It just matters that you can draw one incorrectly, right, to where it touches it twice. Just so that we can kind of see what this would be like, maybe that's 3. We'll call this like, I don't know, 1 and, well, hold on. We'll talk about this point. So we were talking about right here, that'll be 1. And this point, that'll be like, I don't know, 5. We could draw a vertical line through that. So it fails the vertical line test, right? But what would that mean as points, listed as points? Well, those 2 points would be 3, 5, and 3, 1. Right? All I did was I listed those points. Well, we have an x, an input value of 3, and the first time we plug it in, we get out 5. And then we go back and we plug in a 3, and we got out a 1. right? And again, that just doesn't really make sense, right? So the vertical line test is still doing that function rule that we were doing up above, but it does it a little bit faster. It does it a little bit better for graphs. So example 2, determine whether each is a function. On the left piece here, we have another discrete graph with a bunch of points. I can draw dotted lines through all these, and it never touches it twice. This is a function. Another example of a graph would be a line like that, right? You could draw all kinds of vertical lines on that, and it would never touch it. That would also be a function. Next up here, this is like a sideways U. I can draw a vertical line there and it fails, so not a function. If we were to draw one with a bunch of dots on it, we could just have one with there's a dot there and a dot there. And it doesn't really matter what else is on the graph. You could draw a vertical line through both of those, so that would be not a function. Right, so there's 4 different examples there. Next up, domain and range. The domain of a function is the set of all input values. The range is the output values. Normally, almost always, we call domain X and range Y. Domain is input, range is output. So here we want to list the domain and range. On the left side here, there are a bunch of points. So we're going to have to list them as their points. So I start off with writing domain. I'm just going to put a D standing for domain. And because I'm going to list individual points, I'm going to put a bracket here. And that's probably nicer than I'll ever write it again, but that's what it's supposed to be. It's supposed to be a little curlicue thing like that. And the way that I do these is in my head, I think about, I have a pencil. Maybe this is my pencil. And I slide it from left to right. So I'm sliding this left to right. The first spot that it touches is at -2. Then it touches at -1. It touches at 0. It touches at 1. And it touches at 2. And then I can close my bracket. And I'm going to erase these on here. So that's my domain. That's the set of all of my input values. Now for my range, I'm going to call it R. I'm also going to use the fancy squiggly. And this time I have my pencil and it's horizontal and I slide it up. Well, it touches there at 0, it touches at 1, and it touches at 2. Even though at 1 and 2 it hits it twice, you don't have to repeat it. You can. This could also be written as 0, 1, 1, 2, 2, just so that you have one for all points. But that's just redundant, that's unneeded. So you just want to cancel out anything that's duplicated. So you want to get rid of that, get rid of that. All right, so that's if we have just plain old points, okay? Next up here, we're going to have to use an inequality to talk about this. We're going to use a compound inequality, compound and inequality. So my domain, again, I slide from left to right. I start off here at, what is that, -3, and I end up at 2. So I'm going to say -3 is less than, and I look at my graph, it's a closed circle, so less than or equal to x is less than or equal to 2. And that's my domain, right? I have my bookend of -3, and the other side is 2, and x is stuck between the two. Now for my range, I do the same thing from bottom to top. So I start off at -2, it's a closed circle, so less than or equal to y is less than or equal to 2. So that's that. Example 4, determine whether each function is a function. That should say relation. Determine whether each relation is a function. Again, the fastest way to look for this is to see if any x's repeat. So I have 8, 4, 2, 4, 8. So there are some repeats. We've got, let me highlight them in the same color. We've got 8 and 8, and then we have 4 and 4. It doesn't matter which one we look at. We just have to have one case that doesn't follow the rule. I'm going to look at the 8s. I have 8 going to -4, and then 8 going to 4. So this is not a function. Right here, looking at for repeats, I have 0, 2, 4, 6, 8. There are no repeats, so it's a function. Right? I don't even have to look at the output values there. I just know that there's no repeated x's. So there can't be a situation where I plug in x and then plug in x and get a different thing, right? Because we only plugged in everything one time. Example 5. Determine whether the graph represents a function. Well, right there, I can draw a vertical line touching 2 points, so this is not. I'm just going to say no. And then this one here, I can draw vertical lines all over this thing, and it would never touch it twice. This is a function. All right. Lastly, number 6. How many points do we have here? We have 1, 2, 3, 4, 5. Okay. My domain, reading from left to right, I start off at -3, and then I have -1, 0, 1, 3. My range, starting from the bottom to the top, I'd start off at 0, and then 2, and then 3. And again, you don't have to repeat. I know that some of those were used for multiple points. Just list it once. Don't list it multiple times. All right, and lastly, we have this one. We start off with our domain. Domain is left to right. The farthest left point is -2. The farthest right point is 2. They're closed circles, so it's going to be less than or equal to. And domain talks about x. For our range, bottom point is -2. The top point is 2. They're closed circles, so I'm going to say less than or equal to. And range talks about y. All right, and that is it for this section. Make sure that you know that domain is x and range is y. All right, good luck on your homework.